Hey guys, Mr. B here with another demonstration along with Nala. And Nala is here to help out today. Thank you, Nala. So this demonstration is twofold. We've got partially the intermolecular forces that our Module 3 was on, but we're also going to dabble into gases. And you may have seen this before, but I thought I'd give you a little explanation. So I've just got a little tray here to catch the water, and I've got my little pitcher. Got a little mason jar here, okay? I just put a ring on it just for fun. On this mason jar, I'm gonna put some water in this, okay? So I've just got some water. I'll fill it up about half full. Now, what happens if I turn this upside down? Well, gravity is gonna pull it out. But if I take this, it's just a little cardboard piece. It was from Taco, a little cardboard taco box. Okay, if I take that, put it on top, what do you think is going to happen if I let go? If I let go, well, gravity is going to be acting on the water, right? So I let go and magic. So I call this the magic jar demonstration. So this one, right, it's holding it in place. Now, if I remove this, then it spills everywhere, right? So let's talk a little bit about what happened here. So on my whiteboard here, I've got a little jar. This jar is upside down. So what is it that's making the water want to go down? Well, that's gravity. So there is gravity forcing my water down, and it's wanting to go out. But if I put a little piece of cardboard here, okay, that makes a little surface there, and our intermolecular forces, the water is attracted to that. Cohesion and adhesion, the water is sticking to itself. The water is sticking to the cardboard itself as well as the sides of the glass. But there's one other thing that's happening here, because there's some air in here. That air is actually exerting a force, a pressure on the water as well. So what is it that's actually holding that in place? It's not nothing, right? There's gravity, there's something pushing against it. Well, it actually happens to be the air outside, okay? Because right now we're experiencing about 1 atmosphere of pressure from all of the air above us pushing down. Well, that air isn't just pushing down, it's pushing everywhere, against every surface. So there's actually an equal force pushing against our cardboard here and holding it in place, which is why it stays even when I let go. So let's just do that one more time, okay? My jar, water, let's put that in there. Okay, so I've got my jar. Cardboard in place, flip. All right, so once again, we have gravity pushing down. We have air pressure, the air around it, pushing back up against it, keeping that cardboard in place. And what happens when I remove it? Now, wait a minute. Why is this holding in place, right? We've got gravity pushing down, but now the cardboard's not in place. What is keeping this together? Now, it is able to leak out, okay? What's going on? What's going on? Okay, I'll do that one more time. Okay, so what did I do different about this one than the last one? I did the exact same thing. Cardboard, flip, but this time, when I remove it, it stays. Why is that? Well, let's think back to our intermolecular forces, right? There's cohesion, adhesion, there's capillary action, all of those forces holding it together. Water uses hydrogen bonding to hold it together, right? But that shouldn't be enough to hold against gravity, so what's going on? All right, so what was going on? Well, I had my jar and it had the little ring. When I flipped it over, right, it was held in place by my little cardboard. But what you didn't see was I actually had a second jar. Now take a look at this jar, right? It has a little wire mesh on it, okay? So that wire mesh allows the hydrogen bonding, our intermolecular forces, to work, right? And surface tension, this is what allows little water bugs to stay on the water. It's the same thing that was able to hold the water up in the jar itself. So these hydrogen bonding, the surface tension wasn't enough to hold this entire ring the first time I did it, but when I switched to my other jar, this one with smaller openings, you can even see there's water in there right now. Smaller openings, the hydrogen bonding is able to do this. So try it at home. See if you can trick your friends and your family. What'd you think, Nala? Was that fun? Was that fun? Yeah? Woo! Is chemistry fun? Yay! All right, high five. Good girl.